Okay, I'll check to see it. I do have sound, so it looks like we're good to go. As I mentioned in an email or a post, the screencast for um, Wednesday the 28th would be pre-recorded, and that's what this is right now. Of course, on the Friday the 30th is Good Friday, so we won't have any class. So everything that's due this week is due on Thursday. Okay, so I make a point of telling you that. Now, let's talk about where we are in the course, and this just again is a quick review. And I want to say this also. I apologize about the technical difficulty that occurred on Monday. Sometimes up there, I don't know what in the world happens. My computer freezes up, and then I have to just take the battery out of my laptop and put it back in. So I don't know if it's having too much stuff open. I'm not sure what it is, but if we have a situation like that, you know me well enough to know I'm going to pre-record and get that to you. And of course, if you have a question ever, it's a pretty simple process. You send me an email, or if we're in a live screencast, go ahead and raise your hand and ask the question. Well, yeah, as I'd spoken about Monday, and you should have seen the Monday video by now, we've moved into a part of the course where we're dealing with unstructured data. And we kind of got our feet in the water when we did that work with the PAR nonlinear. And I talked about it, the explanation, and how it deals with data that we cannot assume the feasibility set or region is linear. The data are not linear. The data points are. And so we talked about that. Now I have some resources that are related to what we're going to work on today. And this is the cluster analysis part 1, which is chapter 2 in the data smart text. And as I said, see page 36 there on accessing if files are needed. I've also had those files in Canvas. And the book was written by the guy who is the CIO at MailChimp, and they're an email service. I have some information here, okay, and then I have some information about Voronoi diagrams and what they are, and then concave versus convex functions, because we're starting to look now at data that are unstructured, and then some other resources on nonlinear functions. Then on cluster analysis, I have a lot of excellent resources and that help us explain. Well, what you should do, excuse me, first of all, have your textbook with you. Now, this is the Data Smart text, and the Data Smart text is the one that has the picture of John W. Foreman, upside down. Okay, so you'll want to take a look at it. And we're going to work on cluster analysis part 1, which is chapter 2 in the book. Okay, and it starts over there on page 29. Now, as I said on Monday, just by way of quick review, okay, let me get us back down here. By quick review, I had he gives us some information about, he helps us define the difference between unsupervised and supervised machine learning, okay, and what it does. And then he walks us through an example of cluster analysis, okay, or determining the cluster centroid. And he gives us this, he wants to be funny and cool, and so he gives us this story about a middle school dance, and he walks through the process of doing a cluster analysis. Now, if you're a management major, you definitely want to be tied into this, because this is how we identify clusters or segments of customers, and we're going to see that. So we're going to spend some time on that today, and then he walks you through them over on page 33, 34, and 35, okay? And at the bottom of page 35, he starts the case. The K means clustering, okay, in email marketing. And deals with the Joey Bag of Donuts Wholesale Wine Emporium. I know it's exciting, isn't it? We're going to have a case study using booze. What can I say? We're just a bunch of reprobates. All right, now where will you find the files? As I mentioned before, on page 36 of the form and text, he shows you he tells you the link over to the support, the companion website that has the files. I also have them over here, and yesterday, like an idiot, I was having trouble finding them. But here they are, the Foreman files, the zip file, and here it is. Okay. And you should have uploaded the PAR Inc. nonlinear, and I provided you quite an explanation about that. Here are the Foreman files, and this is the file from Chapter 2, and this is the file called Wine KMC. So I'm going to open this file up, okay? And I'm going to save it as yeah, I'm going to call a copy of Wine KMC. I guess that's what they'll call it, whatever. But the last thing I'll put is Harmon Keith. Okay, I'm going to put it on my desktop as an Excel workbook. And just to be certain, I'm going to close it. All right, and I can close that zip file. Then I'm going to go down to my desktop, and there it is. Let me get these three moved over here to Zoom recordings where they belong. Get these out of the way. Sorry about that. I'm doing a little work here for a minute. Okay. Now, I also wanted to, before I get too far into this, let me look at the calendar here for a minute. On April the 5th, okay, I'm going to do a pre-recorded session, part 1. So we won't have physical class that day, and the reason is that I have to take someone to the doctor. It's all the only way I know how to put it. So I'm not going to be able. I'm going to have to leave to get to Oklahoma City to get that person there. So Thursday I have a 12:30 to 1:45 class. I'll be there, okay, and then I will leave. So I'll pre-record a class session for the people who are well, I'm talking about BIS 4403. Forget this, you're in 3603. If you're a student in BISS 4403, that's the day that on the 5th I'm going to have to do a pre-record. Forget it if you're not in that class. Sorry I wasted time. All right, let's look at this. And again, now what he will do is he will walk us through the case. And so you want to be paying attention, because normally what he will do is he'll go tab by tab and looks at, and let's look at what we've got here. He starts us off with the offer information. Now, how many cases has he got? Gosh, I don't remember. He's got the following offers. These are the offers. Now, these folks are offering wine at a discount, okay? And here are some dimensions, variables, fields, attributes, whatever you want to call them. But what we basically have is a table of data, and it shows us the campaign that was when what marketing campaign did it belong to, the type of wine, the minimum quantity, the discount, the origin, and the past peak. Now, let me say this. Let me say this. I would, if you want to see some fantastic videos, fantastic business stories, go over to Hulu, and they have a couple of documentaries about folks that make champagne, and then one about folks that make wine over in France. And it's just incredible what these people are not only just great at manufacturing, they're also really artists. So I'm not pushing wine or drinking or anything at all like that. Okay. I think all things in moderation are fine. I'm going to talk personally. I don't drink for two reasons. One, even if I had a half a glass of wine, I'm going to be the person who'll get in a car wreck and get a DUI. Or I would be so embarrassed if I walked into the store and I was buying beer, wine, or something, and here's my pastor at my church, or people in my Sunday school or my church. So I just don't. I don't touch this stuff anymore. I think there's. Let me tell you what. There's nothing better than sparkling champagne, as far as I'm concerned, or on the other end of the spectrum, a martini. But as a believer, I follow the dictum that if I do something that would weaken my brother or sister, I don't do it. So I just don't. So that's my reasoning. But nonetheless, we've got, and I include this because I thought it'll get you worked up. So you can talk about wine and booze and you do it, and you're actually, you're doing it. You're good. So we have, and then it's past peak. In other words, is it past its freshness or its optimal quality? All right. So we have we have these offers. So we give them a 56% discount on 72 ounces of Malbec if it's past its peak. If it's not past its peak. Okay. And really this should be yes or no. Okay. But they used false or true, but really, and we'll see why we did that here in a minute. Okay, and this tab and the more greatly detailed information about it, folks, is at page 37. On page 38, he shows us the list of offers. Okay, and to get that data, he does a custom sort by offer, and then customize it. So I'm going to do this. He does a custom sort by offer. And so I'm going to take the data, and let's just go ahead and do that. Well, we can see it right here. First of all, we have the offer is in ascending. He has that there in that. The offer number, he has those, that there is in descending order. Well, we can do let's just do a customer, let's do a quick sort. And we'll come over here. And I'm going to do it by offer number. And I'll put largest to smallest. And then a customer, I'm at a secondary level, and I'll do it by customer. I'm sorry, I'm getting ahead of myself. Pardon me. We're gonna see that on the transactions. I'm on page 38 over here. Now, he talks about determining what to measure. And what we're trying to find out is, do these factors, the offer, which somebody is a transaction, they take that offer, they choose it. Are there clusters of people who during that time period who share a definite period in terms of the month of the campaign, the type of wine, the minimum quantity, the discount? So these are things that he believes, the author believes, or the company believes, are variables that or independent variables that motivate somebody to take offer one. Same thing for offer two, and all the way down all those different offers. Okay, so that's the offer information tab. Now we're going to go over to the transaction tab, and I'm so sorry I messed this up there. All right, and here on the transactions tab, we have the customer's last name, okay, and we have the offer number. And here what they've done is they've put the offer number in descending order, all right, and then they put the customer last name in ascending order, in ascending order, okay. And so this is a little bit, if you flip these around, you'd see it. But let's look at Customer Smith. Customer Smith had two orders, and order 2 and order 24. Johnson had 3, 17, 24, and 26. Williams chose 18, 22, and 31. And the reason we did the sort that we did, and I'll click on here, and we'll do the custom sort, and you can see we'll do that right now. By offer, and we'll do that largest to smallest. And then we'll add the customer, and that's going to be in alphabetical order, and boom, there we are. Okay. Now, we can go back out of that, and it will be back to where we were. Okay. So that we can organize the data a little bit, but in truth, this is probably just just by order. Okay, but we're okay. It doesn't matter. We can look at it now. That's the list of offers by customer. So that tells you Customer Smith took offer number 2. These are discounts, and offer number 24. No big deal there so far. Now we come to the pivot table. Now, as I talked about in class on Monday, okay, the Monday session, a pivot table gives us a tremendous tool. And you'll recall that what I did was I took this, I zoomed it out to let you see the clusters, and then I also went ahead and put some fill to let you see it. Now I'm going to start over here with atoms, and I'm just going to take a piece of this array, okay? And if we want to see, we have the pivot table tools. Let's click on pivot table design, okay. We'll do the view and the options, the design. And I always forget about, I want to see the table, how the table itself is constructed. All right. Now, here's what he's done. Okay. He's treated these decisions as binary data. 1, they accepted it. No, they didn't. Now, this gives me an occasion, like I did on Monday, to complain that when you have null and and 1, you don't know what the null really means. So I'm going to take these data. First thing I'm going to do is make them a little more visually, add our visual acuity. And I'm going to come all the way down to row 37. I'm going to click home, and I'm going to put them into all borders so I can see them a lot better. All right. Now I'm going to start here at C1, and I'm going to take Alan, and I'm going to come all the way over to Carter. Okay, I'm just going to look at this group of customers, but I'm going to just quickly show you a little bit of preliminary data work I can do. And I'm doing a little sample here, and I'm just doing a little bit of data mining. And now I'm going to do conditional formatting. I'm going to do highlight cell rules. When it's equal to 1, I'm going to make that green fill with the dark green text, and you'll see those. Now I'm going to come back and I'm going to put conditional formatting, highlight the cell rules. When it's less than 1, I'm going to put in a yellow fill. And now you can really see, you can start to see some clustering. You can see how these data points tend to kind of cluster and you can see these here. So as we back on out, you can see them even a little better. And so we're going to use these factors or attributes to see if we can find, if we do have, if certain types of, if certain offers are accepted by certain group of people and how close they are in proximity to each other. So as he talks about there, all right, we're going to be looking at, we're going to be using some principles. We're going to be using some principles out of geometry, and I have some resources there for you in the website. I'll go back over here to the modules for a minute. Remember, in management science, we always start with a model, and what he's looking at is he's using he's using theories from geometry, okay, about the centroid. How do things tend to clump together? And I gave you these resources to look at, okay? And the distances, silhouette, and determining the number of clusters, what we call a k-means cluster. So we're literally using that type of data, those theories, and applying them. Well, so far we have the pilot, okay, pardon me, the pivot table. This is by customer, by offer, okay. And then starting on page, and there on page 40, he's into the matrix. And here in the matrix is the full set of data that shows us the offer number, when the promotion occurred, the month, that's campaign, the type of product, the type of wine the purchased product, person purchased, you know, the minimum number of kilograms, the discount percent, the country of origin on the wine, and then was it past its peak or not? And we can see it. For example, we can look at here at Adams. Adams responded to a Espumante, sparkling wine, in July, and got it on a 50% discount. Wow. And it's made in Oregon, and it is, of course, it was not past its peak. So we see the matrix, and here we have the customers. This is the full set of data, the full array that shows us everything: the offer, the campaign, the type of liquor, type of a wine that was purchased, the minimum quantity, the discount, the country of origin or place of origin, and was it past its peak? And then we have that by customer. And if I scroll all the way over here vertically, okay, I go all the way over. I'm going to come to this one, DC, okay? Pardon me, cell DC that ends with Young, all right? And then I'm going to come down here. Now, again, if I want, I can go ahead and put these into, I can go ahead and just, I can click up here and put all borders just as easily. And you'll probably want to do that and you'd want to make it a little easier to see everything. Okay. All right. And that's what he shows you over there in figure 210 on page 40. That's the matrix. So now that we have the matrix or the display, okay, we start to do the cluster analysis. And he talks about that process there on page 41, where he talks about four clusters, okay, and seeing if we can divide them into clusters 1 through 4. Okay, so he's assuming starting off we've got about 4 clusters. Now at the bottom of page 41, we start to get some of the theoretical, the theoretical model that guides this, the mathematical model, and this is always what we do in management science. And in this case, Euclidean distance. I bet you never thought you'd have to hear his name again. And let's go over to page 41, all right, and let's look at 4MC. Okay. Now, this is going to tell us the probabilities of someone belonging to a given cluster. Okay. And notice he shows them there in figure 212 at the bottom of page 41, that distance. They're at 8,2 and the cluster center is 4,4. And then he shows you on figure 213, page 43, the Euclidean distance, which is the square root of the sum of square distances in each single direction. Okay? And he shows you that there illustrated in that 1. Okay? Now, I'm going to start over here with cluster, and now, the higher these values, pardon me, the lower the values, the closer they're going to be to higher they're going to be to a given cluster, okay? And so we look at this and we have these data and we classify them in terms of their distance. We use distance to determine what cluster they belong to. Okay? Now, he's got figure 211 shows us that with the 4MC. All right. Now we're going to come down here and click on cell, and I'm going to click on cell A36. And this is going to show us the sum of L38 to D38. And this is the minimum cluster distance. Okay? This computes the minimum distance between those clusters. Pardon me, the total distance. I'm sorry, not the minimum, the total. Now, so we know the total distance. And let's click on cell L34. And here he walks us through that using the square root, and we're doing the Euclidean. We're doing the Euclidean geometry. And he walks us through those equations, starting with the minimization, with the sum. We're going to get the square root of the sum, and then the square of the differences. Okay? We're measuring that Euclidean distance. Now, again, the total distance is L38 to DG38, and that's because we're going to find we're going to get that sum, and that's the minimum cluster distance. So we're just basically looking at data points and their distance from each other. That's really all we're doing here. Now, if we look at here at at cell, again, cell L34. And let me say this also. You will want to avail yourself of some of the resources I have over there for you in understanding this. All right. And here is one. These are PDFs. I'll show you this real quickly. These are PDFs that show how the distances are charted. And I'll walk you through each. I walk you through the equation that he uses, okay, and then the pieces of it. All right, and you download it. Let's just download this thing. I've got it here in my own tortured handwriting, which I think is probably good enough for you to see. And I've got distances, and let me see the view. Click on that for a sec. And we'll have to turn it around a little bit. And I'm going to try counterclockwise. There we go. This shows you the equation for distances. And as I walk you through, okay, each piece of it, and notice he uses the square root function, the sum, the offset, and I tell you how the offset works. Okay. And then the distances and how that's computed. Okay. And the equation. Now, there's a lot here. And for all intents and purposes, we're measuring this central point, or this point where that individual's at, and the distances in terms of rows, columns, and in rows. In other words, the height, which is the number of rows, and the width, which is the columns. And we're using Euclidean geometry. We have this matrix, okay, this array of data, and there are distances between them. And so we compute that. And he walks you through that function. Now, over on page, and that's why he did that in that little introduction to Excel over there. Okay, he showed you that. And the values that are in H2 through K33 use a solver. And I'm going to diminish this down back for a minute, and we'll go back into the okay. And we use the solver to get the values in H2 to K33. And if you go over on page 48, you're going to see that he uses solver, okay? And notice what he does. We're going to minimize the value. We're going to do the minimum, okay? And those by changing the variable cells. And originally they were all blank, okay? And he's going to run the evolutionary. Now, if you take a look at page 217, figure 217, you're going to see, all right, that he can set that the number of times that it improves, or the number of iterations. Now that 600 there means 10 minutes. You probably want to leave it at about 10 seconds, because 10 minutes in that's pretty torturous. All right. And we'll look at the distance here. Okay, here we are. And so you use the evolutionary setting in solver, okay, just to do the setup for the four means clustering. And again, we're just using the Euclidean formula. And notice we've got L2 to L33. And look at atoms. Okay. Minus H2 to H33. And H2 to H33 is for cluster 1. Those are the values. All right. And then versus cluster 2 versus cluster 3 versus cluster 4. And the minimum, we use the minimum function of L34 to 37, and the minimum is 10.44. So this atoms belongs to cluster 2. The smaller the distances, the smaller the Euclidean distance, the closer than that indicate the closer the Euclidean distance, the more likely you are to be a member of a market cluster. Okay. Now, if this all sounds like a bunch of jumbled gobbledygook at this point, which I can understand it does, think of it like this. We know there's an old saying, birds of a feather flock together. And so people of certain income levels live in certain neighborhoods. Okay? They worship if they're churchgoers, they tend to fit a profile. Southern Baptists, tend to fit a particular profile. Presbyterians, Methodists, you name it. Okay? Or people who drive, Ford trucks, or people who buy Chevys, or whatever. Okay? It's the same with these people who respond to these special offers on the line. And the smallest distance to the cluster is 1. Okay? And we use solver to get those distances over there in H2 to K33, and he shows us how to do that using the evolutionary. Now notice this, before, and I want to show you something so you don't get confused, all of these, okay, are in here as values, okay, as numbers, so we can do some work with them. But we got these would originally be blank, okay, and then you'd use solver to do the evolutionary. And I'm going to go in here and I'm going to click data. Now I'm going to go over to solver, and you're going to see we're going to set the objective cell by changing the variables H2 to K33, and we want those. And then we use those same cells as a constraint. That array H2 to K33, we set that as a constraint. Okay, and if we have any unconstrained variables, we make them non-negatives. We don't want any negative values. And then we use the solving method, evolutionary. Now I'm going to open up the options here, okay, and you'll see and this is what he shows you over on page 48, automatic scaling, okay, and then the maximum. Then he shows us the on the evolutionary. Click on that. Pardon me. The convergence, the mutation rate, the population size, the random C to 0, and the maximum time without improvement. This is 10 minutes. You can set this down. It's 600 seconds. That actually, is 10 minutes. You can put this down for 15 seconds, 20 seconds. I've run this, and I guarantee you, 600 seconds, 10 minutes on this is a long time. Okay, but that's where you can customize it as you desire. So he shows you those settings on the evolutionary. All right, and that's where these data come from to get the minimum points, centroids, if you will, against which we compare everybody. Now let's look to the next person, Alan. Okay, and here we see the Euclidean geometry applied with Allen again, and this is Allen's placements versus cluster 2. And you say, how do you know that, Dr. Harmon? Well, you know, all I've got to do is come over here and say, okay, I'm looking at M2 to M33 minus H2 to H33. Okay, and then I'm getting the square root, the sum of that. I'm getting the square root of the sum of that of M2, Allen's choices, minus cluster 1. Pardon me. Yeah, minus cluster 1 squared. We're using the sum of the squares basically to do the Euclidean distance. And then now this time, and what we're trying to find is, does Allen fit within cluster 1? Well, we've got a score there. Does Allen fit within cluster 2? Well, this time we're doing Allen's M3 through M33 versus I2, so to I33. So now we're looking at Allen versus cluster 2. Then we look at Allen versus cluster 3. And then we look at Allen versus cluster 4. Pardon me. Yeah, and then we get the minimum cluster distance. All right, and then we match that. We use the match, and so we know that Allen, pardon me, is assigned to cluster 3, and we just continue this process for all people. Now, one of the other things the author does here is techniques he uses is freezing. He freezes the column so he can scroll across. Okay, and I have an explanation there in terms of the distances and what we're doing with them. Okay, and again, that's in the PDFs over here. I have how many pages do I have on this? I think just the 1 page. There's the PDF. Yeah. So here you see where we've used Solver, okay, to compute the minimum. Right, and we'll open it back up by changing the cells H2 to H2 to K33. All right, subject to the constraints. We're comfortable with that. We've done this, but here's where things get a little bit different. Evolutionary, and we use the evolutionary setting and option on Solver. Now, I think I provide you some resources about that, okay? And there is also, you can click on the options and you can see on evolutionary what they are. Now, here at the bottom of the dialog box, notice this. It says solving method. Select the GRG nonlinear engine for solver problems that are smooth nonlinear. Smooth nonlinear, okay? Like a concave or convex that's almost pure. And that would be marginal cost, say, or marginal revenue. Select the LP simplex engine for linear solver problems, straight linear, we've done those. And then we kind of this thing, the evolutionary engine for solver problems that are non-linear. Okay? Problems that are non-linear. And again, you know, then we have the settings for it. And someone calling me, which I'm not going to answer. And then we have the maximum time that we set this for, as you can see. Now I'm going to shut this off for a second. And now we find that which cluster we've assigned all these people to a cluster. Okay? And so that's 4MC. Now, he decides then to take us through 4 clusters, okay, with the top deals by cluster. All right? And this is going to be over on over on 219. Pardon me. But yeah, you see some more of there on 49. On page 49, 219 talks about the 4 optimal cluster centers and making sense of them. Okay, and we've really done that. Okay, now we're ready to move on over and to get the top deals by cluster. So he walks you through some of the mechanics of translating the data that are in tab 4MC over here. And let's talk about what we've got going on over here. Now, we have the totals of each taken. Here on figure 221, we have the total of each deal taken broken out by customer. Okay? And then we do some sorting on them. Okay? And you end up with that result, as he shows you at the bottom of page 51, that when you sort out on cluster 1, it's Pene Nor, I guess is how you would pronounce it. And so we find out, you know, the top deal by customer, this is, you know, what customers responded to what offers the most. And I'll show you that. You can see the equation. He uses the sum if. And this is the middle, page 50. He walks you through that. The sum of one if is the range of cells to evaluate. That's the assigned cluster. That's back in 4MC. And then the criterion is 4MC minus top deals by cluster. Okay? We're using the sum if function, so we choose the array, then we set a criterion, okay? And then we indicate the actual cells to compute. So if you look at the middle of page 50, you're going to see equals sum if, and that's the assigned cluster, the range of cells to evaluate, the comma, okay, and then the criterion, and then the actual cells to sum. And if I'm not mistaken, I think I provide you information on the silhouette. So we'll go back here for a second. I can make this a lot easier for us. I'm going to pop up here. I'm just going to take that and I'm going to copy it. And I'm going to put it into a notepad. It'll be easier for you to see, and I'm going to break it down for you. Okay? Now, when you do the sum if function, okay, the first thing you have to have is an array, an assigned set of cells to look at. And notice here it's 4MC, that's the name of that worksheet, 4MC. And we're going to use the cells L939 to DG39. I'll go back over here for a moment and take a look. Okay. And we're looking at L39 to DG39. And I can come down here to row 39 and really do that. And that's the assigned cluster. So we're using that as the array. Okay. Now we're using the SUMIF function. The thing that makes this complicated or seemingly complicated is the fact that you're working with some large arrays and he's doing a reference back to another piece of the worksheet and a different tab in the worksheet, excuse me. Then we've got 4MC minus the top deals by cluster. Okay. And that's HS1. Okay. And that's our criterion. All right. And then, okay, if the criterion is met, what do we add up? Or sum, and there are the cells. So that it's a seemingly complicated. Now, let me say this. Taking this and, you know, reverse engineering it, it's pretty easy to put this together and to be able to string these functions in and to take the Euclidean equation and put it all together. This is why it's classic management science, but dealing with new types of data. It's classic management science, okay? But it's also, you know, we're dealing with, we're applying the evolutionary model and we're determining clusters, things that tend to stick together. And so we've got that computed, and then, you know, we take the cluster that they belong to and we use conditional formatting here. Okay, and I'm going to click home and I'll click conditional formatting. And I'm going to put manage rules, and you'll see that we're using a graded scale that applies to H2 to K33. And of course, the greater the hits or counts, the greener that becomes. And we sum those. And so we start to get a picture of, yeah, what, you know, the top, what cluster, the number of top deals, and the number of deals by cluster. Okay, and as he says in cluster 1, it seems to be the Pinot. And he has us do that offer date, and it looks like to me there he's got, well, he's got the offers. He's got them filtered out. And he does H. And we'll sort, and we're going to sort largest to the smallest. And there we replicate what's there in figure 222. Now we can do the same with 2. Okay. And do the same thing with 3. We can go over here and get rid of that. And we can come over here to 4 and do the same thing. So that's basically it. And he makes some comments there about the top deals by cluster, okay? And I'm going to walk us back through some of the changes we made so we're where we want to be, all right? And for number 1, we'll just scroll down here. Now, you wouldn't have to filter with the conditional formatting, because the darker it is, the higher the number, the more it is. Well, we can see, for example, that for cluster 1, okay, the deal that really drew people in was the Panay Nor during September, and from Italy, 34 ounces and 34 milligrams. Okay, now, again, as I've said before, you really do need to be on top of, how this all works itself out in terms of the interactions of these variables, okay? Now we're going to do the distances, and again, over there over there I have the distances, and you can download that, and I give you an explanation of how he got that. Okay, and again, he's using the square root. He's using the offset, and I explained about that. You want to take a look at it? Okay, and then he walks us over to a silhouette. Okay, now the silhouette basically says, how far are your neighbors from you? And he just basically says at the bottom, page 53. So he said, okay, if these folks are my neighbors, okay, it's how close are they? And obviously, the smaller the distance, the closer you are. Now over here on the 5MC, and I don't want to take too, this is going to be a long video cast, and I understand that. When you go through here, okay, and you're working with this, and look, folks, if you hit a certain point with this is going to be a long one. Just stop and go back and recall where you were, and you can go back and look at it a second time, okay? But it bears the time. Here he decides to go with 5 clusters, and then he repeats the process, and then the silhouette, okay? And here in the 5 med C, all right, and he walks us into that tab. All right. And we've gotten the average differences, and now we're trying to find the median, because the median is the closest between them. And then we look at the 5 median for the top deals by customer. And that lets us look at or see if we have a score high enough, a distance high enough to say, okay, five clusters. Now we've got a total distance there of 42.8. Okay, let's go back here to And here we had a distance of 140.7. And again, we're trying to see if, we can, how close we can get it, or see how close they are. And they're over on page, starting on page 70, he talks about the 5 medians clusters. Okay, and there they are. And then the top deals by them. And that's, that's pretty much it. Now, again, you'll want to follow through the book. If this is one you really want to sink your teeth in, there's a lot here. I've glossed over it. Now, you'll want to upload the file to get the credit for the workshop. But let me say this. You could probably spend just a good month working through all of this and seeing, using this tool. And again, it's one thing to reverse engineer these. This shows how smart this guy is to pull it back. And if you take a look over on page 528, when they sort on the clusters, okay, it's Pinot, as you can see. And we got some improvement in the distances. Now, he shows us a way to compare these, but it does seem to a certain extent we got the 5 minute a lower distance, okay, going to 5 market clusters, more finely tuning the data. Could you go to 6? Of course you could. Could you go to 7? Up to you. And for this one, I'll come over here and I'll click data. We'll click solver. We want to find the minimum. So that these are all binary. And then we go back to the evolutionary model. There we are. Okay, folks, well, that's it for Wine KMC, the cluster analysis. Now, let me say this, all right? This course is an introduction to data science, to management science, all right? It's not it's not going to give you an exhaustive set of information. But remember the key, here are the key things to remember. First of all, do you have the correct variables? Okay, the offer number is the dependent variable. It's the variable of measure. It's the one I count. These are the independent variables that I assume are related to a person's decision to accept or reject the offer, which is binary. And if we're not quite sure how this all fits, then we use an evolutionary tool. All right, and we tried it with 4 to get the distance, and then we tried it with 5. You could do it with 6, and I think he does it in there, and you don't get much of an improvement. But certainly taking that distance from 140 down to 42 or whatever it is, here it's 42.8. Back on 4MC, it's 140. You definitely have 5 clusters, and you can take it to 6, and I think he does but in the text and talks about it, but you just don't get that much. You don't get that much of a finer cut. So are these really the independent variables that are the most important? Okay. So these are your decision variables. This is, of course, what you count. And is this important? Yes, it is. They took the offer or they didn't. That makes sense. Then, all right, is there a model out there that I can use? And we use the Euclidean model. Okay, of distances on a plane. Sounds like you said, I thought I never had to use Euclid's name again. I understand. Classic management science, so we use that model. Okay. Now I've got some resources over there for you about Bironi diagrams. Okay, and then the third and most important thing is to know what model do I use to throw in the solver, and we use the evolutionary. Now we use the silhouettes, the 5MC silhouette. Now here's the silhouette value. And how close are we? And this is distance from people 1, cluster 1, cluster 2, 3, 4. The closest to second, my community, silhouette values. Okay, and we can look at the 4MC silhouette. We'll scroll up there. And we'll see. So based on silhouettes, all right, it's a little confusing, okay, because we're still kind of clustered together. But when we come to the silhouettes over here in 5MC, the 4MC, and look at the 5MC, it's not much of an improvement. But certainly if we look at average distance, total distance, excuse me, that's a remarkable change. So, and he says to a certain extent, we're disappointed that the silhouettes aren't greater. But there's, these are people who buy wine, okay? And it may be they're not that easily segmented. Okay, well, that'll take care of that, and again, upload it for credit. I'm going to close this off now. All right, and we will have just done, and again, we've gone through all the classic stuff we do in management science, and here we see, and notice that he really didn't use real sophisticated statistics. What makes it seemingly complicated is the most complicated of all the functions in here, okay? The most complicated is going to be the offset. The offset just looks at height versus depth, columns and rows. Height is the rows, and depth or width, excuse me, is going to be the columns. And then how distant are they? And there he shows you using that illustration. And I'll go back there. At the heart of all of this is page 43, figure 213, where he shows you how Euclidean distance is the square root of the sum square distances in each single direction. And if that squared root, sum of the square roots sounds familiar, it's definitely one that shows up when you compute the standard deviation. Okay, and that's how we get a standard deviation. We take the square root of the sum of the differences squared. Okay, thank you so much, folks. This is going to be a long one. Like I said, you may want to stop, and kind of take a little break, and then come back and take a deep dive. All I can say is, you look at this book. This young man is very, very intelligent, very impressive, and a fantastic use of the tools that are there. I've never seen anybody use Excel like a database in my whole life, but it's a great way to show us how versatile this tool is and how powerful it is to have that, to follow the management science methodology. Methodology meaning my approach and how I go after these, which is why I emphasize that. Folks, thank you so much. And this is the pre-recording, and I will, it looks like that, when is it next week? It's on the, I believe on the 2nd, I think on the 2nd I have a medical appointment, so I may pre-record the 2nd. I'll have April the 2nd. I think I'm gonna have to check and see that on my calendar. Okay, if I do, I'll pre-record and have it there for you. Thanks a lot and have a good one.